Welcome to my YouTube channel. In this video, we'll be discussing about logarithms. If you are new to this channel, kindly help subscribe to this YouTube channel, My Simple Maths. You can help share any of our videos and like them. And if you are not new to this channel but you have not subscribed, please help press the subscription button and activate the notification bell so that you can always receive notification from us whenever we post a new video. Now, straight to the business of the day, we'll be considering logarithms. So, like every other topic in mathematics, there are some rules, laws guiding them. Logarithm is not an exception. There are some rules, there are laws that are guiding them. The moment we are able to identify those rules, we'll be able to solve as many questions as possible. So, the basic law of logarithm. Let's look at some of what we have here first. If a number y can be written in form of a raised to power x, then the index x is called the logarithm of I to base a. By that I mean, if y equals a raised to power x, then if you are changing it to log, it's now going to be x equals log y to base a. I'm sure we can see what is on the screen. Now, the implication is this. This base, if you're having it in this form, this base is base a. Look at it, everyone. This base, which is the base a, is going to carry this s as power if you are changing it away from log to this form. This a here will carry this x as the power. That's what we have here. This a is going to carry this x as the power. Then it will equate to y, because we are going to make use of this as we journey through this video. So that is what this statement is all about. Then if log is given without any base, then the log is said to be in base 10. If you're having any log without a base, that log is naturally in base 10. So when you see such, you know such log is in base. So let's look at the laws in details now. Law number 1 says log a times b. Whenever you see any log of this form, a times b, this times there may be there, it may not be there. You can have ab. If you have ab, it's still the same thing as a times b. So, but if you have any log of this form, the meaning is log a plus log b. Because from our idea of indices, by the way, if you have not seen our video on indices, kindly check this YouTube channel. From our idea of indices, we're able to understand that multiplication goes with addition, while division goes with subtraction. So, if you have log AB or log A times B, the result will be what? Log A plus log B. The second one, if you have log A divided by B, log A divided by B, the result will be what? Log A minus log B. And lastly, if you have log A raised to power n, the result will be what? N log A. By implication, it means this n, which is the power, will just move to the back of this log. And that's what we have here. So any value we have here, we just move to the back of the log. Beautiful. So these laws that are here, we'll be able to understand them better if we have some questions to back them up. So we are going to solve 1 or 2 questions to understand how we solve log. By the way, this set of logs, we solve log in this form. That is log without using table. These are logs without using table. So let's get some questions. Now we have some questions here. The first one says evaluate the following. Log 9 base 3. We have for the second one log 8 base 16. We have for the third one log 1 over 81 base 3. The second question says we should simplify log 27 minus log 9 plus log 81. While the third question says we should solve this equation. Log s to base 2 equals 3. The second one, log s to base 5 equals minus 2. The third one, log s raised to power 4 minus log s raised to power 3 equals log 5x minus log 2s. While the fourth question says we should evaluate log 9 minus log 3 plus 1 over 2 log 81 all over 2 log 3. So let's dive straight to solving those questions. So we are going to be applying our laws, some of those laws that has been explained earlier. So we start from the scratch, from little questions that we have here, then we'll move higher as we journey through these questions. So let's go. Solution number 1. The question says we should evaluate the following: log 9 to base 3. Whenever you have question of this nature standing alone, just represent it this way. Just let's say x equals log 9 to base 3. Let's call it this way. Now we apply our law. The first one, let me just refer to it now because we may not go back to it again. This is it. We say x, we let x equals log 9 to base 3. Now it's now in this form. S equals log y to base a. That one says s equals log 9 to base 3. So what we'll do is to carry this, our base is going to carry this power. The base will carry the power, that is a raised to power x. That's what we have here, equals y. So we are going to be applying that a lot. So we now use this power now, this base to carry this x as the power. So the 3 raised to power x equals 9. Awesome. So now that we have something of this nature, 3x equals 3 raised to power x equals 9. So now 3 raised to power x equals, we want to see how we can do it such that this number and this number can be the same, because 3 raised to power 2 is still the same thing as 9. Awesome. So we can now cancel out our 3. Our 3 can cancel out because they are now the same. Our 3 can cancel out because they are now the same. So we now say this 3, we cancel out this 3. Awesome. So we'll be left with what? X equals 2. So our final answer is what? X equals 2. Let's go to the second part of question number 1. The question says we should do what? We should evaluate log 8 to be 16. Log 8 to be 16. Beautiful. As usual, I will say let x equals log 8 to be 16. So as usual, we just use this our base to carry this x that is here as the power. So we now have 16 raised to power x equals 8. So we now have 16 raised to power x equals 8. So what are we going to do? Just to make sure these two numbers are the same. If you say 2 raised to power 4, it's going to give you 16. Naturally, 2 raised to power 4 will give you what? 16. So we now have 2 raised to power 4. But on this power, we have x there initially. So the x will still be there. So we have 2 raised to power 4x, because 2 raised to power 4 ordinarily is 16. Then this x that is there will multiply. So we now have 2 raised to power 4x here. Now for this 8, 2 raised to power 3 will give us 8. 2 raised to power 3 will give us 8. So our numbers are now the same. So these 2 can now cancel out. These 2 will be left with what? 4x equals 3. Will be left with 4x equals 3. So to make x the subject of our formula, we just divide here by what? By 4. We divide here by 4. So that the 4 can cancel out 4. X will stand alone. We will now be left with what? X equals 3 over 4. Beautiful. Now to the third one. From number 1, we have to evaluate log 1 over 81 to base 3. As usual, we just use our base to carry this x. So it will be 3 raised to power x equals 1 over 81. So we have it here. 3 raised to power x equals 1 over 81. And from our knowledge of indices, 1 over means raised to power minus. Raised to power minus. So because this 81 is raised to power 1 ordinarily, anything raised to power 1 is that thing. Because 81 raised to power 1 is still 81. So this 1 over 81 is still the same thing as 81 raised to power minus 1. Awesome. So let's see how we can make these numbers the same. 3 raised to power x equals 3 raised to power 4 will give us 81. 3 raised to power 4 will give us 81. But we have minus 1 here. We should not forget. So if this minus 1 multiply this 4, it's going to change to minus 4. Beautiful. So our 3 raised to power x equals to 3 raised to power minus 4. So that this 3 can cancel out this 3. our x will now be what? Minus 4. Awesome. Now, solution number 2. Solution number 2, the question says we should simplify log 27 minus log 9 plus log 81. Awesome. The same thing, just have to apply our law little by little. Now, log 27. If you look at 27 is still the same thing as 3 raised to power 3. 9 is still the same thing as 3 raised to power 2, because if you say 3 raised to power 2, it will give us 9. Then for 81, still the same thing as 3 raised to power 4, because if you say 3 raised to power 4, it will give us what? 81. Awesome. Now, as usual, let me refer to one of our laws. The last one here. Beautiful. We have log a raised to power n. The result will now be, this our n will go to the back of the log. We now have n log a. The same thing we have here. We have log 3 raised to power 3. This our 3 we go to the back of the log. We now have 3 log 3 minus this our 2 we go to the back of the log. We now have 2 log 3. This our 4 we go to the back of the log. We have 4 log 3. Awesome. If you look at this, something is common. Log 3 is here, log 3 is here, log 3 is here. So we just, since they are common, we bring it out. So we now have 3 here. This is the 3 minus this minus. We have 2 here plus this 4 is here. So we just bring out the log 3 that is common. So if you say 3 minus 2 will give us 1. 1 plus 4 will give us 5. So that's why we now have 5 log 3. Awesome. Straight to solution number 3. The question says we should solve the equation. Now, unlike the first one, we are just asked, it's not in equation form. Like whenever you have this equality sign in a question, that's where the equation comes from. Equate. So we say log x base 2 equals 3. That is where the equation comes from. So it's just almost the same thing with the first one we solved. The difference is just that this one is put in equation form. So the same thing we are going to do. We just use this our base to carry what is here. We use this our base to carry what is here. So x is standing alone already. We just say 2 raised to power 3. And 2 raised to power 3 is what? Is 8. Because 2 times 2 is 4. 4 times 2 is 8. The second one, as usual, say we should solve the equation log x to base 5 equals minus 2. We just use this our 5 to carry this minus 2 as the power. Our x is already standing alone. So 5 raised to power minus 2. Whenever we see this minus as from the power, it means 1 over. So this is the 1 over. We now have 5 raised to power minus 2. Since our x is already standing alone, 1 over 5 raised to power 2 now is what? 25. So our x is what? 1 over 25. Now the third one, the question says we should solve the equation. This equation, let's look at it. Log x raised to power 4 minus log x raised to power 3 equals log 5x minus log 2x. Beautiful. Now looking at this, what we need to do is to segment them. Those ones here, we call them our left hand side. And those ones here, we call them what? Our right hand side. So that we can simplify them and make our job easier. So let's see the left hand side. We say let log s raised to power 4 minus log s raised to power 3 be our left hand side. And log log 5x minus log 2x be our right hand side. So we solve our left hand side and solve our right hand side. We now equate them together. So okay, let's see from our left hand side, what do we have? Log s raised to power 4 minus log s raised to power 3. As usual, we bring this power, like we've just explained, to the back of the log. So this is it. We now have 4 log x minus, we bring this power to the back of the log. We now have 3 log x. Awesome. Log x is common. Log x is here, log x is here. So we just bring it out. We just say 4 minus 3. Look at it, 4 minus 3. So 4 minus 3 is 1. So we now have 1 log x. You can leave it as log x because anything times 1 is still that thing. So you can say 1 log s or you say log x. So that's for our left hand side. So let's see our right hand side. What we have on our right hand side is what? Log 5x minus log 2x. Now look at this, everybody. Let me quickly refer to it. Because from our law number 1. Law number 1, beautiful. Like we've explained, we say log A times B is log A plus log B. And I said it earlier that this times here, if it is not there, we just have AB. If you have AB, it is still the same thing as A times B. So if you have log AB, it will give you log A plus log B. So also, if you have log A divided by B, it will give you log A minus log B. We are applying this law now to this question. Beautiful. Now we are here on our right hand side. Log 5x. Log 5x is just like saying log AB or log A times B. Log 5 times x will give us log AB will give us what? Log A plus log B. Now log 5x will give us what? Log 5 plus log x. Now this minus, this is it. The same thing, log 2x is just like saying log AB will give us what? Log A plus log B. Now log 2x will give us what? Log 2 plus log x. That's our rule that we make use of there. Beautiful. So let's open up this bracket that we have here. Log 5 will stand plus log x will stand. This minus will open up this bracket. So minus times log 2 will give us this minus log 2. Minus times plus log x will give us this minus log x, because minus times plus will give us what? Minus. We have opened up this bracket. Awesome. So we now have log 5 plus log x minus log 2 minus log x. Something is happening here. We have plus log x here. We have minus log x here. So plus log x can cancel out minus log x. Awesome. So we'll be left with what? Log 5 minus log 2. Beautiful. Log 5 minus log 2. Remember our law that we say minus goes with division. It's just like saying log A over B is still the same thing as log A minus log B. That's what we have here. So we have log A minus log B will give us what? Log A over B. The same thing. Log 5 minus log 2 will give us what? Log 5 over 2. So we've been able to apply those laws. So on our left hand side we have 1 log x, or you can say log x, and on our right hand side we have log 5 over 2. So let's equate our left hand side equals our right hand side. So on our left hand side we have 1 log s, or if you can call it log s, and on our right hand side we have log 5 over 2. Beautiful. So this our log. Can cancel this log that is here. We'll be left with what? 1x, and 1x is still the same thing as x, so we have it here. We'll be left with 5 over 2. So that's our answer. Awesome. So let's dive straight to the last question that we have here. Question number 4. The question says evaluate log 9 minus log 3 plus 1 over 2 log 81 all over 2 log 3. We are still going to be going through our route. It looks complex, but if you follow it step by step the way we've been doing, it's going to be very easy. So let's go. Log 9, because we have 9 here. 9 is still the same thing as 3 raised to power 2. This is it. Minus, we can't split 3, so let's just leave it. 1 over 2 is here. 81 can give us 3 raised to power 4. Beautiful. Over 2 log 3. Nothing can be done to this one, so we'll leave it here. Now for this, as usual, this is our power. We go to the back of the log. So it will be 2 log 3. This is it, 2 log 3. Minus log 3 is standing alone. We have 1 over 2 here already. This is our power. We go to the back of the log. That's why we have 4 log 3 here. Beautiful. But looking at this angle here now, 1 over 2 times 4 is just like saying 4 over 2. There are ways, if you say 4 over 2, it will give you 2. That's why we have this 2 here. Or you can say 2 here 1, 2 here will give you what? 2. That's why we will have this 2 here. Awesome. So we now have 2 log 3 minus this log 3 that we have here. Plus, instead of this now, we now have 2 log 3 all over 2 log 3. Awesome. So Now we can now say log 3 is here, log 3 is here, log 3 is here, log 3 is common. So we can just bring this log 3 that is common out. So this is it, log 3. Beautiful. What is left? We have 2 here minus anything times 1 is still that thing. So we have invisible 1 here plus we have 2 here. So we can now say since log 3 is out, we can now say 2 minus 1 plus 2. 2 minus 1 plus 2. That's what we have. Log 3 is common here already, because if you use this log 3 to open up this bracket, you have what you have up here. So if you say 2 minus 1 will give us 1, 1 plus 2 will give us 3. So we now have 3 log 3 up here. This is 3 log 3. Down here we have what? 2 log 3. So that's why we have 2 log 3 here. Beautiful. So having done that, this our log 3 can cancel out log 3. So we'll be left with what? 3 over 2. So this is it, 3 over 2. That's our final answer. So we have come to the end of this video. Please don't forget to help subscribe to this YouTube channel and like any of our video. You can also help share any of our video. This particular video is about log without using table. I want you to stay glued to this channel, because as time goes on, we are going to release video on how to solve log with table. Thank you.